Hey everybody, this is Larry. This is day 28 of the LeetCode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. I am very tired. I ran 15 miles today, and probably by itself it's already tiring, but I had two back-to-back speed days of about 17 miles total. So with effort. So today I am just too old to be in shape for this. But in any case, so we'll see how this video go. I'm already not really talking, at my usual speed, but sometimes in life, as in with all these things, you don't really get to choose how you are when you need to do something, right? So well, and today maybe I'm not 100%, maybe I'm at 50%, but let's take a look at this problem. But don't worry about me. Tonight I will have a very good sleep, and tomorrow I'll feel really good, hopefully. So yeah, feel free to watch this on the fastest speed because I am going to go slowly today. I can't even breathe right now. Alright, 2285, maximum total importance of roads. You're given an integer n denoting the number of cities in a country. The cities are numbered from 0 to n minus 1. You're also given a 2D integer array roads where road sub I is equal to a sub I, b sub I. Okay, they're bidirectional roads. You need to assign each city with an integer value from 1 to n, where each value can only be used once. The importance of the road is then defined as the sum of the values of the two cities it connects. Return the maximum total importance of all roads possible after assigning the values optimally. Okay, I think this seems like a very my first instinct is that well, it's just greedy, right? And as soon as you hear greedy, if your first question is, why is it greedy? How is it greedy? Prove that it's greedy. And those are, I would say to you, that's 3 questions, not 1 question. But that means your instinct is in a good place. That should be your first thought, is to why greedy works. And the way that I always do it is some sort of exchange argument is one. This one is a little bit easier to demonstrate because for this particular problem, you have the sum of stuff, right? And when you're summing stuff, not always, but when you have 2 equivalent choices, then it's very easy to make that exchange argument. And here, for example, I'm going to be a little bit lazy. I'm not going to lie. I already kind of talked about how I'm just at 50% right now. Because I'm running. I was running, I think my lungs is the thing that is I don't know, it's just I have trouble talking right now, to be honest. But the idea here is that, okay, let's look at this example 1, right? If you look at this example 1, you can say that you could assign, let's say the default value that they do is assign 5 to node 2, right? And 4 to node 1, right? And the reason is because in a greedy way, node 2 has 4 edges outgoing, or just 4 edges in general, it's bidirectional. And node 1 has 3 edges, right? So even ignoring everything else, you can you could calculate the contribution to the answer of these 2 nodes, right? So you have 5 on node 2 with 4 edges. So that means that it's going to be 5 times 4 plus 4 times 3. Reasonable, right? Because that means that the 3 roads are going to 4, or outgoing of 1, which has the value 4 and the 3 edges, right? And the exchange argument here is very easy, right? What if we want to exchange these two so that we put a 4 here and a 5 here instead. And of course, that's a very easy math to do, because then that's just 4 times 4 outgoing plus 5 times 3. And of course, you can very easily see that, this doesn't work. And you can also generalize this a little bit, right? So, I mean, here you can see that the math, you just figure it out. But you can also see that it clearly doesn't work. But in a more general sense, and this is the exchange argument, is that so it doesn't make sense to make this exchange. And then you could kind of use it. I'm hand waving a little bit here because I don't know. That's my excuse. But you could use the induction to kind of just do it for everyone, right? Like now now you do this for the top one and the top second. You use the exchange argument. You be like, okay, well, the top one is optimal. So then now you do it for 2 and 3 and so forth. And here, of course, you can generalize it. Here you can say A in the node X. It has I edges. I don't know. I'm running out of variables, right? J edges, right? So then here we assume that for now I is greater than J, meaning that node X has more degrees than node Y, right? I is greater than J and A is greater than B, and the contribution to the answer is going to be A times I plus B times J. And if you want to exchange them, then it's just going to be B times I plus A times J. And then the question is, well, now that we exchanged them, which one is bigger, right? Which one is bigger, right? And here you can kind of use the fact that I mean, we could do a couple of things. Maybe we can just collect the i's, right? So then now you have A minus B times I, and then you want to compare it to oh, I have capital J. That's why I was like, what's going on? A minus B times J, right? And here then now, because A is equal to B, this is positive, right? And this is positive. And because this is positive and this is positive, and also, did I do this right? I guess so. It's just so weird because you could also divide this because A is not equal to B. I guess it could be, but it doesn't. But but because this is bigger than that, and I is greater than J, or this is positive and I is greater than J, you could see that the left is going to be bigger than the right, right? So that's basically the idea. And if you exchange them, then it's going to give you a better, a worse answer. Anyway, I understand that. So that's basically the idea for the proof. It's not I'm not gonna lie. Like it's not that's most of the stuff. There's some hand wavy things in there for the exchange argument, but like I said, my apologies. I'm just so tired today. I can't wait to go to bed with air conditioning and a bed that is probably too soft for my back, but still a bed nonetheless. And just watch TV. I don't even watch I don't even have a TV, but just watch random YouTube stuff. I don't know. Actually, I've been watching the the U.S. Olympic trials for track and field. It's been very exciting. It's yeah. Anyway, all right. Let's say we prove this. So let's just solve this problem, right? So let's just say we have degrees. We have let's just put it as a counter, and then we have for xy in roads, right? We just do x increment by 1, y increment by 1, right? And then now maybe and the actual nodes don't even, the keys don't even matter. We could just do degrees dot value. Is it value or values, right? So then now we can do for index D and enumerate the values, and maybe we can just do what is it, n minus index times D, something like this, right? And then just sum it up. And this is just and maybe I definitely went a little bit too fast on this part, probably too fast that I got it wrong. Why did I have it wrong? Dun dun dun. Index n minus Why do I have it? Whoa. Man, I am too. Oh, I'm dumb. I need to sort this. And we could. How I intended this way is sorted in increasing order, but I think maybe, well, in decreasing order, but the other way is fine too. So yeah, I'm just being dumb. Did I miss a thingy? I did miss a thingy. For some reason, in my head, I already sorted it. I clearly didn't, but as I said, I'm operating on 50% right now, right? Oh, what? Oh. Okay. Sloppy. That's why I did it in sorted order, I think, in my head. But it is a trick. I wouldn't say it's a trick case. I wouldn't say it's a trick case, but it is an edge case that I think this handles. But I kind of just changed it, and then I thought they're equivalent. But yeah. The reason is because they're nodes with 0 degrees, and because when they have 0 degrees, the values don't show up. I think if I had created, instead of using a counter, if I had used an array, maybe if I just do like 0 times n, then you would not have that issue. And then yeah, is it? Yeah. Then now we just and then now you could write it back that way. Huh. That's a very peculiar edge case, I suppose, but not a big deal either way. I mean, I don't know. Like I said, I'm 50% sloppy. But the reason why this works is just because, yeah, we don't care about the node labels. We just care about the degrees. And the higher the degree, we want to match it with the higher the thing. And of course, if you sort it, depends on which order you sort it, because then now you can also say it the other way, which is that the lower the degree, we want to just give it the lower, whatchamacallit, importance or whatever. So, or the lower labels to give it a lower contribution or whatever. So yeah, I'm exhausted. This is n log n for the sorting of degrees. You could, yeah, I don't know. What a silly mistake. But yeah, this is O of n time. This is O of n time. It's just gonna be dominated by this sorting. After that, it is, yeah, and it's O of n space due to this. I wonder if you could do better, but I have no energy to run it today. So let me know in the comments if you could do better. That's all I have for today. Let me know what you think. Thanks for watching. Leave a comment in the support. You know, I know that today my energy level is a little bit low, because my energy level is a little bit low. So please give me a little bit of support in the comments. And thanks for watching. I'll see y'all later and take care. But I even said the outro wrong. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.